Hi everyone, this video is an exercise 11 the challenge question. So we are given this equation and a and b are integers such that a is between 0 and 10. So we want to find two different pairs of values for a and b. Okay, so this is an interesting question and it needs a trick. So first of all, we just need to integrate the left hand side, right? So again, this is the form that the numerator looks like the derivative of the denominator. So we can always start with the len of the denominator as our first guess. So let's say this is our educated guess, len ax plus b. Now, if you differentiate this, we'll have a over ax plus b. But as you can see, on top we have 1. So we also need to have a factor of 1 over a so that 1 over a cancels out with this a. Okay, so that means when we integrate 1 over ax plus b, we'll have 1 over a len ax plus b. And now the limits are 11 and 5. And then on the right hand side, we have 1 over a len 41 over 17. Okay, at this point, we can just substitute the values. So we have 1 over a len 11a plus b minus, so I'll just take a factor of 1 over a out, and then we have len 5a plus b. And now we have 1 over a len 41 over 17 on the right hand side. So at this point, we can cancel out the 1 over a's on both sides. So, and also we can rewrite the inside the brackets as len of 11a plus b over 5a plus b, and now here we have len 41 over 17. Okay, now we can basically do use the exponential and just do e of both sides. So e to the power of len 11a plus b 5a plus b, and then e of len 41 over 17. That's just because we can get rid of the lens, and then that's going to be 11a plus b over 5a plus b, actually just the modulus of that. And then on the right hand side we have 41 over 17. Okay, now this part is interesting because we have the modulus of something is equal to 41 over 17. So that means that if you want to solve this equation, there are two possibilities. So either 41 over 17 is positive or negative because we have modulus on the left hand side. Now, let's first look at the first case. That's when we have positive. So if 11a plus b over 5a plus b is equal to 41 over 17, so positive. Now we just need to solve this equation. So we just need to do a cross multiplication. 17 times 11, that's the first thing we do, and that's 187a plus 17b is equal to 205a plus 41b. Now we just simplify this and we'll get 18a, and then let's keep b on the right hand side, minus 24b. So we can divide both sides by 6, which gives us 3a is equal to minus 4b. Now, at the start of the video, I mentioned that we need to use a trick, and that's here, because at this step we can't go further, but we just need to look at the question logically. Because in the beginning, if you remember, it said that a is between 0 and 10. And also, if you look at this equation, it's saying that the 3 times a is equal to 4 times b. So that means whatever the value of a is, whatever the value of b is, we'll multiply that by 4 and we'll get a, which means that a is a multiple of 4, right? Because imagine if b is 2, or actually let's say b is minus 2 because a is positive. So if b is minus 2, then we are doing minus 4 times minus 2, which is 8. So this is the value of a, right? And that just means that, or actually this is the value of 3a in this case. But the point here is that, yeah, this wasn't the best example because the numbers don't work. But the point here is that whatever the value of b is, it's being multiplied by 4, and therefore the value of a is a multiple of 4 between 0 and 10. So now if you think about this, there are only two possible values for a between 0 and 10 that are multiples of 4, right? A can be either 4 or it can be 8. These are the only possibilities. And now we can just find a value of b for each case. So if a is 4, then b is equal to, so 3 times 4 here and then minus 4b. So b is minus 3. And for the second value, we have 3 times 8 is equal to minus 4b, and b is equal to minus 6. So these are actually the two pairs of values of a and b, but we haven't finished the question yet. So for the second case, we need to consider the case that the right hand side is negative. So we have 11a plus b over 5a plus b is minus 41 over 17. But this case is very easy because we'll have 187a plus 17b is equal to minus 205a minus 41b, and we just need to rearrange. So 392a is minus 58b, and then b is simply equal to minus 196 over 29a. Now the reason I rearranged in this way was to just show you that the value of b isn't an integer, but if you remember, the question says that a and b are integers. So because this fraction is a decimal, and a decimal times a, whatever a is going to give you another decimal and a real number, basically. So yeah, the point is that at least b cannot be an integer. So therefore, since b isn't an integer, then this case doesn't give us any solutions, right? Because b cannot be an integer. So yeah, the two pairs of values of a and b are the first pair 4 minus 3, then 8 minus 6 as the second pair.